begin with our online webinar, and I feel privileged to introduce our speaker, Mr. Pradeep Paleli. He is the co-founder and CEO of Thanos Technologies, Hyderabad. Pradeep sir has received his BE honors in the electronics and instrumentation from BITS Pilani in 2008. After a brief stint at Infosys, he delved into the world of startups in 2011 with his first role as the managing partner in a carbon management and renewable energy consulting company called Efficient Carbon. Thanos is his third startup, and he manages business and operations at Thanos. Founded in 2016, Thanos is Telangana's first drone manufacturing and services company with core focus on agricultural spraying. Thank you, sir, for being with us. Handing over to you, Pradeep, sir.
Thank you, Manasa, for the kind introduction. Good evening, everybody. My name is Pradeep. Without further ado, more about my company. Let me quickly start by sharing my screen. Please confirm if my screen is visible.
No, sir, it's not visible. You can share your screens.
How about now?
Yes, sir.
Oh, okay. I think there is a bit of a lag on my side. Just give me a few seconds. Right. So, in terms of the presentation itself, I think we can structure it in a manner where I would give a brief of what drones are in general, what kind of drones are there, of the different types and configurations of drones. And then we can quickly move to the various kinds of applications that are there. And so we basically are a drone design and manufacturing company based out of Hyderabad. And our main core focus area, I would say, is in agriculture. So I'll maybe spend another 10 to 15 minutes after the initial introduction on the agricultural drones that we make, the use cases there, the applications. And after that, I'll always spend about 5 to 10 minutes on certain use cases we had identified. So this is something we have been sharing with college students everywhere, wherever we meet them, including GRIT, the previous batches. Certain interesting areas on which you could work, develop new applications on software front, hardware front, and multiple areas which require different kind of students coming from different academic backgrounds to work together. So, and any point during the presentation, please feel free to ask any questions. I would prefer that it be more of a Q&A than a one-sided dialogue. So feel free to ask any questions in between. In case anybody is not able to speak in between also, you can please note down those questions or put it in the chat box so that we can take them up in the end. Right, so with that, let me just briefly start by brief introduction to drone. Dr. Ramesh, can you confirm if everybody is able to hear me and see the screen as well?
Yes, sir. Yes, sir.
Okay, great.
Thank you, sir. Okay, sir.
Right.
Continue,
so I'm pretty confident most of you or maybe all of you would have seen a drone like this. This is a Dji Phantom, popularly called as a camera drone or a marriage photography drone. Nowadays, any wedding or any major event you attend, you will see a drone like this. Maybe a different version of this. This is, I think, Dji Phantom 2 from 2017, 18 or so. There are much more iterations of this as on date. But typically, this is how it looks. A very popular drone for photographies, used in multiple applications, not just marriages also, but even during COVID, there was quite a bit of monitoring happening with this. Now, this has become a de facto standard in terms of photography or various applications in India. But now the scenario is slowly changing, wherein we have local manufacturers coming up. Even during COVID and various other rescue operations across the country, whenever we had floods, Uttarakhand floods a couple of years ago, and various natural disasters that have struck different parts of the country, drones are more like first responders as on date. Previously, it was a completely different scenario. Probably ministers and others used to travel by helicopter or some other method to take an aerial view of the situation. But now, that kind of aerial review has changed to such an extent that you can deploy drones and live stream it to any part of the world, not just any part of the country. So anybody who is not even present in the same place, same state or country can still review what's happening there through live video feed option that has been shot from a drone. So there are various Indian manufacturers also as on date who are providing this service, making excellent top-class, world-class drones which can stream video and different types of data in a live mode directly to the operator or over the internet to any device across the world. Now, when it comes to drones itself, so granted, this is a pretty common drone you might have spotted. There are smaller and bigger drones of various configurations as well. But pretty much all drones can be categorized into 3 or 4 basic types. One of which is what we call single rotor. It looks more like a helicopter. As you can see from the design, there is a single rotor at the top. And oftentimes you might see a tail rotor, which is used for yaw or rotation of the direction, whereas the top fan, propeller, rotor, whatever you may call it, it is responsible for vertical movement of the drone or the vehicle. The one at the tail, which is sitting at the back, that will be controlling the direction, basically. So this is very similar to an helicopter, which most of you might have already seen. So we call it a single rotor drone. So all drones that we're talking about today are unmanned aerial vehicles. There are no manned versions that we're talking about. There are ambulance drones where humans are also a part of the picture, but we're not talking about that today. We are talking about unmanned aerial vehicles. The first type is the single rotor vehicle. It looks something like this. And these drones also have different kinds of applications. The top right drone that you see, now quite a few of you might see that name at the top, which says Phaser. Now, I'm assuming some of you might be aware of Yamaha Phaser bike. Different versions of it have come and gone. You're not wrong in assuming that this is also a Yamaha company. This Phaser is also from Yamaha, Japanese company. And Japan has been probably the first country in the world to adopt drones for agricultural applications. Japan, it's not surprising to note that Japan has been using drones since the 1990s. We have started seeing these drones in India only 4 or 5 years ago. But imagine 1990s, Japan used to use these petrol-powered drones. And naturally, that has come out because of lack of manpower. Japan has an aging population, old population. It's a developed economy as well. There are not many people, labor, to actually work physically on the fields. So they've been going towards automation for quite some time. So that's a Yamaha Phaser drone, which can be fitted with agricultural spraying payloads or even a camera that you can see at the top. The lesser the number of rotors. So the basic concept goes that the lesser the number of rotors, the more efficient a drone is. obviously, because the lesser the power consumption. If 4 motors are there, they will naturally be consuming more power as opposed to one motor. But obviously, that will put a limit on the payload weight itself, how much it can carry. Accordingly, you can choose motors or engines as per that. And the next type, what we can come to, is fixed wing. So these are basically aeroplane kind of structures, as you can correlate with the normal aircrafts that some of you might have flown. This is also popularly used in hobby domain. In case any of you have built hobby aeroplanes or know friends who have built aeroplanes as a hobby, this is how they broadly look. In fixed wing, so these are called fixed wings because of the nature of the construction itself. They have fixed wings like birds or aeroplanes, non-removable wings, which are responsible for the lift of the drone itself. The wings are the ones which are responsible for taking the drone off the ground and onto the air. And once it is at certain altitude, they glide like an aeroplane or a bird with minimal power consumption. Now, fixed wings have different kinds of applications again. I'll come to the difference between a fixed wing and a multicopter in a bit, once I talk about multicopters as well. The third and most common drone type you might have seen, which is what all these DJIs or other camera marriage photography phones are, we call them multirotors. Multi essentially means more than one, and rotor is basically the propeller or the motor at the top, the combination of it, which is rotating in order to create that lift. So anything more than one, you could call essentially a multirotor. More commonly in the commercial application domain, we see 4, 6, or 8 rotors, and we call them quadcopter, hexacopter, or octocopter. In this slide, you will be able to see the top left, top right, and the bottom left, which are all quadcopters, which have 4 motors and 4 propellers. The bottom right is a hexacopter, as you can see, with 6 motors and 6 propellers. And there are different configurations in these as well, as in 8 rotor or octorotor doesn't essentially need to have an octagon configuration. A quadcopter can have 8 motors as well. We call it a coaxial quadcopter, wherein 4 motors are at the top and 4 motors are at the bottom. So technically speaking, it has 8 motors, but you may not call it an octocopter strictly. It's a coaxial quadcopter. And there are technical reasons as to why someone would choose that. We can discuss that in detail in case someone has any questions of what more number of rotors serve as a purpose to deliver in terms of payload or thrust. The last one I would like to touch upon is hybrid VTOLs. Now, if you take a close look at the picture, you would be able to make out that it is a combination of an aeroplane and a quadcopter. Dr. Ramesh, just a minute. I think there is some issue with my screen. It's not moving back and forth. Just give me 1 minute, please.
Okay, sir. Okay, sir. Please.
Hello, Dr. Ramesh, am I audible?
Yes, sir.
Yeah.
Continue, sir, please.
Yeah. Is the pace okay so far? Am I going too fast or too slow?
Sir?
Am I going too fast or too slow? Is the pace okay? Do you
Yes,
want
sir.
me to
Yes, sir.
maintain that?
Okay, sir. Fine, sir. Fine.
Oh, okay. Yeah. So just to close the discussion on the different types of drones, this is what we call as a hybrid VTOL. VTOL essentially stands for vertical takeoff and landing. As you can see in this picture, you have aeroplane-like wings, which is a fixed wing kind of design, but a multi-copter-like top-facing motors also, which is why we call it a hybrid. And all multicopters are basically VTOLs because they take off vertically and land as well. But the moment you make it into an airplane kind of design, it becomes a hybrid VTOL. Now, why do you have so many kinds of designs, and why do you have to make newer shapes or combinations of this? Is because fixed wings have their own advantage in terms of high endurance. A fixed wing drone, because of the nature of its wings, it can fly longer by consuming lesser power. Typically, they fly more than 2, 3, 4 hours. There are fixed wing drones which can fly for 8 hours, 16 hours, 20 hours as well. But one drawback is that fixed wing drones cannot stand in the air. They have to keep moving. And multicopters, because they can stand anywhere, because they take off vertically, they move in any direction by using all their motors. Unlike fixed wings, which can make use of the air and glide, they consume much more power, which essentially means they do not fly for too long. They can hold their position. They can do various kind of things like drone deliveries or point surveillance, various kind of things. But they cannot fly too long because of the nature of the power consumption of the motors, which is why they have combined these two to come out with a hybrid VTOL design, which will have advantages of both. So it sits somewhere in between a pure fixed wing and a pure multicopter. So it will have higher flight time. It can take higher payload also. It can stop midair also. And this is a design typically we've seen over the last 2-3 years that people have worked on for drone delivery specifically. It can take more weight and it can travel farther. So that's why hybrid VTOLs have become a little bit popular over the last few years. Just to touch upon the applications a little bit. Now, you might be reading about drones in the news, WhatsApp videos, YouTube, wherever. Over the last 5-6 years at least, they have been made very popular. Previously, it used to be only the other developed countries, be it US, Europe, or Australia, where we used to hear one new application every week or every month. Now, in the last 5 to 6 years, India has adopted drones in such a fashion, thanks to the current government, which has been pushing it by understanding what this technology can do in various applications. Previously, even in India, the first point of entry naturally was in defense. Defense is where quite a few new technologies are tested. Indian Army, as on date, uses quite a few types of drones for various border patrolling, surveillance, and now newer applications are coming in terms of dropping bombs as well, wherein people do not need to go, wherein humans can be spared by sending a drone for dangerous missions, where payloads need to be dropped, where spares need to be dropped, food supplies, spare parts, or whatever. Multiple applications in defense sector itself, and that's where drones have found their first application. But over the last 3-4 years, we've started seeing them in the commercial or consumer space as well. We've been seeing that government has been using drones for mapping entire villages of India, and we, as such, Thanos has been using drones for agricultural spraying operations. Other than this, there is the police department and others who've been using it for law and order maintenance, safety. There is gas pipeline monitoring. There is electrical pipeline monitoring, electrical cable monitoring. Sorry, wind turbine inspections are happening. Solar power plant inspections are happening. You name any domain, drones do have a role to play. Wherever you need an eye in the sky, an aerial point of view, drones are solving that problem as on day. And more new applications are coming up with each passing day. So here, this slide mentions industrial monitoring and security, be it high security government applications or even simple private companies as well. You want to measure how your stock or inventory is doing in a very large area which is spread over square kilometers. It is not possible for a human or security team to be monitoring each and every point continuously at certain frequency, despite the number of CCTV cameras you might be having. Having an eye in the sky gives you a much bigger and broader picture in terms of the view. Offshore inspections, like I said about the wind turbines, which are not easily approachable by land naturally because they are placed in the water. Oil rigs, structures of the oil rigs for which you need to spend human resources, boats, etc., for viewing difficult to reach areas. Drones can do that. power infra applications, for example, wind, solar power, electrical power wind, the top left corner, disaster management. Uttarakhand gets had it, and quite a few other unfortunate incidents that have happened even there. Drones have become the first responders, fire incidents or natural disasters as well. A few others, just to name them, remote asset monitoring. That is somewhere where humans don't need to be there full time, but let's say a very remote telecom tower or a gas pipeline which runs across hundreds of kilometers. You can't have a person standing at every kilometer, or you can't have someone monitor it each and every inch. But let's say, imagine scheduling a drone inspection once a day, 8 o'clock in the morning, and set the time, and the drone takes off, does its job, either does a live video feed or stores the data and comes back, and then you can assess, analyze, and take action. Delivery UAVs, these are rather newer applications where medical delivery is taking quite a bit of prominence. Previously difficult to reach areas, previously remote areas where people could not have access to medical care at all, or used to get access to medical care only after a lot of waiting. Imagine 15-20 kilometers road taking 5 or 6 hours. Northeast, this is an even bigger issue because of the hilly terrain and landslides that happen in rainy season. Even small distances take hours of time. And let's say if an entire road itself collapses, then there is no possibility of delivery. It may take days or weeks itself. So there, drones are revolutionizing how medical care is delivered, be it vaccines or snake bite, antivenoms, different kind of applications for that. Food delivery and all, yes, it's a fancy thing that's being talked about, and Amazon has been doing it in some parts of the world. That may come maybe later than sooner, but the critical application remains medical care. Once the use cases are shown, slowly you'll start seeing it in other segments also. Military spares and supplies, interfacility transport. We've heard about Swiggy doing a small pilot project with drones trying to deliver inventory or items between their own points so that they can quickly deliver it. Instamart, for example, they have different hub and spoke model where between their own hubs, drones can quickly transport the items so that from that point to the customer, it becomes much more faster. Shore to ship is one application which one company in Singapore is trying out. Electrical cable laying, this is something we ourselves had made it drone for a popular infrastructure company, where we have showed them how to lay electrical cables at a height of 100-150 feet by using drones. You don't need humans risking their lives anymore to lay electrical cables. Drones can do a fairly decent job over there. So briefly, I'll touch upon what we ourselves are doing in agriculture, because that's the core area of focus for us. I'll be able to give more insights on what we have been doing, in which direction industry has been going as well. What we've discussed so far is a broad discussion on drones, types, applications. But now we're coming to agriculture, where any application in agri comes into two domains, either automation or intelligence. And we focus mainly on automation. And when I say automation, basically anything to do with spraying liquids or solids. Agriculture typically is a heavily manual activity. There is automation coming in. I wouldn't say automation, mechanization. Quite a few developed countries already have mechanization in agriculture to quite an extent. Pretty much all aspects are mechanized. The reason for that also is that in developed countries, farmers do own hundreds of acres, in some cases thousands of acres. It's not physically possible for individual people to cover those kind of areas in a short period of time. So mechanization has inevitably happened there. In India, we mostly have small farmers, marginal farmers, the average land holding being less than 2 acres or so. But still, nevertheless, there has been a growing labor problem. In case there are any students in the call who have farming background families, in case your parents, relatives, anybody is involved in farming, you can go home and ask them what kind of problems they are facing today with regards to agriculture. The first and foremost would be that labor is not available. There are very few areas where labor is abundantly available, but even that becomes a problem in the peak season when everyone needs them. But otherwise, in most places, labor is a major issue as on date, and COVID has made it even worse. So today, we need mechanization and then further to that automation in a major way in various parts of agriculture. We have taken one critical aspect which happens during the cropping season, not pre or post cropping, which is related to spraying nutrients, fertilizers, herbicides, or pesticides. So almost any agriculture field out there growing any kind of crop needs some kind of spray for controlling pest attacks, and every plant naturally needs nutrients to grow. Now, because of the labor issue, mechanization is certainly inevitable, but even mechanization, manned mechanization also is not sufficient in some cases. For example, if you take a tractor can reduce the burden on humans who previously used to do manually, but it doesn't solve the problem completely, wherein some crops are not even suitable. Rather, tractor cannot even get into certain kinds of crops. If you take paddy, for example, paddy is a high density cropping. Tractors do not go into paddy crops in quite a few states across India. Some people still crop it in such a manner that tractors or narrow tractors may get in. But otherwise, paddy or rice as we call it in common terms, it's a completely manual activity starting from sowing to spraying to harvest, not harvesting, but up to spraying stage. So here is where drones have found most amount of application. Just to take an example, in the last 3 years, we ourselves using our own in-house built agriculture spraying drones. We have done about 3,500 acres of spraying across Telangana and AP. It's a small area compared to the millions of acres that we have. But nevertheless, in that 3,500 acres, we've seen that 2,800 acres or so is completely agricultural pad. And this is because of the demand that is coming owing to the heavily manual activity that is involved there. And we have understood that this is needed more and more across the country in other crops also. And we are constantly updating our product and the service model as well. So these are some of the problems that mandate the requirement of drones in most of the crops. I touched upon only labor shortage, but anything that is done manually, as you can imagine, has certain kind of inefficiency, wastage of the resources or the chemicals itself. And if you talk to any of your farming, any of you who are from farming background families, if you talk to your parents, you would soon realize or understand that it's a very hazardous activity to spray chemicals manually. People do fall sick when they inhale these chemicals by not wearing proper protection measures. So all these combined have given rise to this need where the manual intervention in this process needs to be minimized. That's where drones come into the picture. How do they fare? To give you an application standpoint of view. Rather than looking at everything just technically, you also need to look at the end application where the commercials, certain intangible benefits, differences come into the picture. This slide basically talks about that. Manually, where a human can do about only 1 acre per hour, a drone does 6 to 8 acres per hour. Manually, the costs are extremely high and they keep going up. And with drone, with efficiency, it can go down. But here, the price is more not on the cost of the spraying itself, but the chemical usage. Because drone spraying is so efficient, the chemical quantity usage is also reduced. It sprays more efficiently. It solves the problem, be it nutrient shortage or pest attack, more effectively. That's where it is more useful, on a more beneficial on a financial standpoint as well. And because there are no humans standing in the field at the time of spraying, it's completely safe in the sense all the hazardous elements that are there, they have been eliminated. Here, let me quickly try to, okay, maybe I'll share the video towards the end. So this is how our drone looks. Various first in the class features. It's a completely designed and built in India drone. We make our own lithium-ion batteries also to power these drones. And at present, we have one of the highest flight times in the country for a battery-powered agricultural drone of this size. This is just a picture of how much work we've done so far. Now, I'll give you a minute to go through this testimonial from one of our farmers. This will give you a picture on what the customer thinks. So far, I spoke about what we think as a product builder, what we think is useful. But only when an end user farmer validates it, that's when you know that what you've made is actually useful and it's going to be adopted even further. So this farmer has validated whatever problem statements we highlighted, the time it takes, the more efficient manner in which it's placed. So this is where any product you design or any solution you build, if it is for the market, you can't build it just for fun or just because you can. It's important that you try to solve a problem. And when you try to solve a problem, first you need to understand the entire crux of the whole problem. It could be financially, could be technically, from all angles, you need to understand the problem 100%. And then you try to start addressing it, whether cost needs to be reduced, whether the effectiveness of the product itself needs to be improved. From different angles, you need to think about if the end user has to actually appreciate and use your product or the solution. Product essentially doesn't mean just a physical product. It could be a software as well. What can these drones do? Crop protection is one thing. You can actually do seed dispersal, forestation, fertilizers can be sprayed. Mosquito control has been happening in Hyderabad. We are the ones who demonstrated to GHMC. Various applications. There are quite a few applications here. Just for those of you who are interested in what drones or agricultural drones can do, there is plenty of opportunity in the manufacturing sector. There is plenty of opportunity in rural entrepreneurship. Pesticide distributors, all these guys can own drones and set up service line itself. There is plenty of opportunity on a village or mandal level to set up a complete drone service shop. It's same way you have tractor or car motor mechanics, you need drone mechanics as well. That's about agri-automation. Agri-intelligence has to do with collecting imagery and trying to analyze them to give useful insights. Essentially, these are the different types of maps. Rather than these words, let me show you the pictures that make more sense to you. This is what we call as a contour map. This is a 5-acre plot which has been mapped using a drone, based on which it created certain height-based data elements. So all the numbers you see here, minus 1.9, minus 2.1, all these are the relative altitude at that point, which means if there is a point that is 0, these points are so much lower than that point. So it gives you a numerical data representation of which points in the field are at what height. But this is not sufficient. This is what, if you talk to your civil engineering friends, they might be using something called a total station or some other tool to create a contour map or a layout of an empty land. This is the kind of output they usually give. Maybe not so high resolution, but this is the usual output. But here, you can't even see the field. You can just see a bunch of numbers. What if you could see the field on top of this? That is, you take this map, you overlay on this, and then you see the actual field and identify which part is which. And then you add another layer. So this is what is called an orthomosaic or a satellite view or an eagle eye view, you could say. What if you could add elevation map? So this is my car at the center of this 5-acre plot. And clearly, in this map, you can see that my car is at a higher altitude because it's about 1.5 or 1.6 meter height. You can see that as a red bump. Now, this typically gives color-based imagery where the red parts are high and the blue parts are low. So basically, from the top left corner towards the bottom right corner, the level is decreasing. Now, some of you may be surprised, but this is actually the Gandipet Lake. 5 years ago, when I used to first fly my drone in the Gandipet Lake, it was completely empty, not a single drop of water. Now, the lowest point, the blue point, is where some water may have been there, but otherwise the entire Gandipet Lake was empty. Now, see it today, it's completely full to the brim. Back then, some of us hobby flyers used to fly drones over there. So I took the opportunity to map the a 5-acre bit over there. So this is another level of data points. This is a terrain texture map. So you might think this is a cement wall or something because of the color, but you can get a touch and feel kind of thing where the bumps are the high points and the uh, depths are the low points. And then there is a vegetation map in agriculture. You can see which part is vegetative, which part is non-vegetative. Simple insights. You can do measurements, area measurements, length, distance measurements, volume measurements in case of mining industry, major application of that. Drones are being used across. So even insurance industry is currently using it for crop cost estimates as on day. So these are broadly the applications when you consider in agriculture, when you take data, but same drones, different kind of cameras will give you different outputs in any domain out there which needs some kind of area data. So you can imagine, maybe some of you can propose new applications as well during a Q&A session, and I can clarify some of those. But it's mostly left to imagination where you can think of new application. So that's where I will conclude the applications discussion. I'll spend maybe 5 minutes just to take you through the use cases I had in mind. I think we are already at the end of almost 45. Yeah, I will take maybe 5-10 minutes for this. Is this slide visible, Dr. Ramesh? Focus areas and problem statements.
Sir, yes, sir.
You're able to see this slide, which says focus areas and problem statements?
No, sir, no, sir.
Achha, okay. Let me. How about now?
Yes, sir, got it, sir. Yes, sir.
Right. So these are similar problem statements I had given to GRIT team a couple of years ago before COVID started, and these still remain the same important problem statements when it comes to drones. So let's go one by one. We have a total of 3 problem statements or areas, focus areas rather, I think would be useful for you to focus on and work on. The first one is sensor integration. Other than for hobby purpose, pretty much any kind of application out there would require some kind of payload or sensor. It could be data gathering, or it could be payload delivery. It could be pesticide spraying. There have to be some sensors that are integrated which do some intelligent work by themselves. So that's where you need to figure out various kinds of sensors required. It could be a camera, it could be a LiDAR sensor to detect the range, whatever it could be. So here, the work involved, I would say, would be identifying the sensor for the application that you choose. What kind of firmware is required to be written? It could be in different languages, C++, Python, or any other language out there. What kind of firmware and software coding is required to integrate the sensor with the drone? And then once this is done, how do you club this, integrate it, and test for the actual application you had in mind when you started the work? Different applications for this, just to name a few, would be indoor navigation. Huge potential for warehouse management. If you go to the airport or somewhere nearby, if you just travel around the ring road, ORR, you see such huge warehouses of 2 lakh SFT, 3 lakh SFT, Amazon, Flipkart, delivery, all these guys. Now, how do you think people would be identifying the items in those warehouses across such a massive area where the items are stacked one on top of the other to a height of 3 floors or 4 floors? Certainly humans are not doing that. If they are doing, they're not going to do it for long. There are robots, on-ground robots and drones also, which are doing this job. We had quite a few inquiries for these kind of applications as well. Same thing goes with industrial applications for chimneys. Take a coal thermal power plant, for example. Any of you have been to Vijayawada, BTPS, or any other thermal power plant? Some of you might have seen KGF2, right? So in KGF2, they might have shown those long towers in KGF area where they do this mining. Those towers are basically cooling towers or exhaust towers, where the insides or the outsides are currently required to be mapped using drones for structural integrity. How good is it? Is it cracking? Is it breaking? Is there any damage? Humans cannot do that naturally. So drones are being used over there. And whenever we talk about sensor, one important application that has been coming up in the recent past is GPS denied environment navigation. all these outdoor applications we're talking about require some kind of GPS for them to be positioned at all times, for them to be positionally aware to do the work they are doing, to give that feedback to us and also to do their work. But what if you have to work in a place where there is no open sky? GPS requires open sky, which is why you don't get GPS signal sometimes, pretty much always if you are in the parking or if you're underground or anywhere. So GPS doesn't penetrate these kind of tech surfaces. So you need to be in the open area. But imagine you are mapping a closed mine or a building, an old archaeological site, or a very small drone that needs to map big pipelines, gas pipelines or water pipelines or any of these kind of applications where you're not exposed to the open sky. That's where GPS denied environment navigation comes into the picture. Quite a few research labs across the country are working on it. It's a very important and useful area of application. Coming to the second focus area is object or target identification. Let's say you have this sensor, you get the data, but there are cases where you have a camera, but what good is it if you can't take an action based on the inputs that you're getting? Let's say in the case of be it defense, or let's say you're doing a perimeter inspection or surveillance of a cement factory spread across 500 acres. They have their raw materials placed somewhere, but there is no 24/7 surveillance. There is only wall or fencing that is there covering the entire area. How do you make sure that in case there is a trespassing, how do you detect instantaneous? Detecting it after a day or two is a different case, which a manual patrolling team can do. But if you have to instantly do that, there is a periodic this thing where the drone keeps traveling, it keeps capturing images. Either it can do onboard data analysis or it can send to a central control room where analysis happen. And that's where, based on the change, what was the previous image, what is the present image? Is there a hole in the wall? Is there a cut in the fencing? It will compare that imagery and it will highlight a difference, saying here is an anomaly. You might have seen these in some movies recently where they're using drones and high-tech applications as well. So any change, these algorithms use and showcase that difference. Let's say you want to capture a thief or a criminal who's running away. The police department has this use case as an important one. You need to be able to track that vehicle. On-ground teams may lose sight of it. If there's an aerial, if there's a drone in the air, let's say, constantly it will keep logged on it and it will keep track. So these are certain applications where object identification, target identification, and taking action after that is very important. Again, here you require sensor inputs, analyzing them, and here there is a role of computer science graduates, so basically someone who's interested in machine learning and those kind of domains, needs to write new machine learning algorithms or build upon existing ones to achieve high level of accuracy, so that you have basically 98% of level of accuracy to keep track of the item or tag it as and when as it appears. To simply put in simple words. Again, integration testing is required for pretty much anything like that. And this again has applications in multiple domains, like listed at the bottom. The third one is a bit offbeat compared to the previous two focus areas. If there are other domain candidates here, maybe metallurgy or other candidates may be more interested. But nevertheless, this is an important area for anybody to focus on. If you're building a drone, you need to build it as light as possible. Most hobby or college students use glass fiber frames that we find somewhere. Some use aluminum frames as well. But in the professional scenario, we use carbon fiber. Some go even step further to use even lighter aerospace grade composites as well. So these kind of materials is something to be explored. What newer materials, what newer kinds of batteries can you build or configurations can you build in order to extend the flight time of the drone itself? One major difference between drones and electric vehicles on the road. People typically club these two sometimes when it comes to power and battery. But one key difference is that because electric vehicles are on the road, they are not working against gravity. So they don't have too much of a I would say, bothering with regards to the weight. But in drones, because they have to fight gravity at every instant, each and every gram becomes important. And because of this fight against gravity, you don't achieve those kind of high flight times that electric vehicles can. Electric vehicles on the road can. It's common sense, basically. So here, how do you extend flight time so that you can do more and more work without the drone coming back for swapping of the battery? So say that is very important. What new kinds of materials, what new kinds of lithium ion, lithium iron phosphate, sodium air batteries, all this becomes important. And we constantly do this kind of research as well. We may not identify new materials, but we are always on the lookout for new types of battery cells out there so that we can build better batteries for our customers. That is something we constantly focus on. So this is the third and final area, I would say. What do you essentially need to work on this? For those of you who are absolute freshers and have not done any work on drones so far, for any kind of sensor integration, obviously there has to be an onboard sensor first of all, an onboard processing unit. A very basic processing or computation unit would be something like a Raspberry Pi 3 or 4. And what you see in the center is a small camera, Sony camera. And the one on the right is a NVIDIA Jetson Nano, which is a high-end computation board compared to Raspberry Pi. There are even higher-end computation boards like Jetson Xavier and a few others, which may be a bit heavy for the smaller ones. Jetson Nano is one of the smallest high-end computation kit, I would say, out there, which can analyze live stream videos, 2 streams, 4 streams, and give instantaneous responses. So this is what you call as edge computing. Edge means essentially instantaneously it is happening on the drone itself or on the device itself. Another way is where you don't need that kind of instantaneous results. You just stream everything to a control room. There the analytics happen. So either of these, you need these kind of sensors and computation. And the backend software, obviously. So this is about some of the sensors or the devices you need. Flight control, which is the basic aspect. The entire drone platform itself. GPS in case you are developing outdoor applications. LiDAR or ultrasonic sensors if you're trying to gauge your surroundings, what distance you are at, how do you land autonomously, how do you move inside a room without hitting the walls. For that, you need these kind of sensors. And then the software, basic PC laptop software that we have. Free softwares, Linux, Windows, C++, Java, all these are available. So a combination of all these is what will give you a final application. Thank you. That's it from my side. We can move to Q&A. Anybody has any questions or about the focus areas? That's it from my side, Dr. Ramesh.
Okay, sir. Thank you, sir. Any queries? Sir, question from Preeti, sir. Preeti Vandam shared question in chat window. Can you tell about the ranges of the drones and their technical capabilities? Sorry, technical capacities like battery charging, height of flight.
Right. So, Preeti, this is different for every drone. Just to give you a couple of examples, our agriculture drone, for example, has a total weight of 30 kg when it is in the air. It can do a maximum radio control range of 1.5 kilometers, but that is because you're not supposed to fly agriculture drones beyond your line of sight. You should be able to see the drone when you're flying. So we do not go even beyond 500 meters. But there are surveillance drones which go up to 10 kilometers, 20 kilometers. And if you connect them to internet by 4G LTE or 5G LTE, you can go to unlimited range. You can sit in India and control a drone in US or Europe. That's how it is right now. And the flight time that we have for this drone, the heavier the drone, the lesser the flight time. We have about 20 minutes of running time. But there are drones in multi-copter format which go up to 60 minutes that we have built. In fixed wing format, we have 2 hours, 4 hours, 20-hour drones also on the military front. So, yeah, I hope that answers your question.
One question from Raghavendra, sir. Sir, can you explain about traffic and obstacle detection?
So, yeah, I think some people have already done some sample pilot projects here across the country. So here, basically, you have a camera which has a zoom facility more often than not. because at the height at which drones fly, you won't be able to figure out quite a few things at that distance. You have zoom cameras, typically 10x, 20x zoom and all. Once you identify it, you can take action accordingly. As in, if you're talking about controlling traffic, that's a different thing. You go way back where the traffic is yet to start. You try to analyze the density of vehicles per kilometer of the road or per 100 meters of the road, and you try to understand that it is about to get into a gridlock kind of fashion, or whether it is a pretty smooth traffic. Those kind of things can be done by identifying the vehicles. So first thing is that the camera should be able to segregate each and every vehicle, and then there should be a counter where it keeps adding. And once the time passes, or it could be based on time or it could be based on distance, you can simply put a counter where you can identify how many vehicles are there, based on which you can create a logic that can decide whether it's a okay traffic or an increasing traffic. So that's a very high level this thing that I came up with just now, but there could be different kinds of implementations that you can think of as well. Obstacle detection is required only when you're flying in places where there could be obstacles. For a surveying drone which flies at 400 feet height or so, there are no obstacles, so you don't essentially need them. But if you are going inside a room or inside a forest or at a very low altitude where you might run into buildings, let's say, yes, that's where you don't need a camera sensor essentially. You may even have a simple LiDAR sensor or monocular lenses that DJI uses. You combine multiple of these sensors and you put a good algorithm. It does even 360-degree obstacle avoidance. So the choice of camera or the sensor is also something that is important, depending on how you club it. Obstacle detection is one part, Raghavendra. Obstacle avoidance is a different ballgame altogether. If you detect an obstacle, you may be able to simply stop there. But what some advanced drones from DJI, Skydio, and these other drones do, they go over the obstacle. Now, there is a very complicated algorithm inside which says whether you have to go above the obstacle and go, or take a left and pass by, or right and pass by. So all this you need to get simultaneously multiple sensor input and accordingly take an action. I hope that answers it. Parthu, okay, I have got some direct messages from someone called Parthu. Right, so I think his question has to do with agriculture, where can propellers of the drones cause damage to plants? So, Parthu, this is a very good question wherein quite a few people don't think about it, but someone who's seen it or can imagine it can come up with a question like this. Thank you for this. So, valid question, but we've not seen this happen unless the plant is in a very early, delicate stage. Usually, you don't use drones to spray at certain kind of that kind of a stage. The plants are already strong. We've worked in rice, cotton, mirchi, and cotton where even the flower was there, but even the flower didn't drop because you don't fly too close to the plant as well. You maintain certain minimum height, something like 5 feet or 8 feet, and depending on the wind, you adjust the height up or down. But essentially, we have not seen any damage to the flowers or plants, mainly because you don't stay in one place. If you stay in one place, that is a problem. But if you keep moving, because when you're spraying, you keep moving, then you don't see any damage. If you by mistake stop anywhere, because of that continuous high thrust, there could be small damages every now and then. Hope that answers. Pushika has a question. How can we make agriculture drones relevant with small farm holdings? Interesting question, Pushika, given that we have mostly small farm owners in India. 85% of the farmers have belonging to the marginal and small farmer category. So this is where the size of the drone comes into the picture. How do you deliver the service to them? The business aspect, the service delivery aspect come into the picture. People have been asking us for bigger and bigger drones to cater to the farms. We think it's a good idea to go smaller and smaller when it comes to marginal or small farmers, because the bigger the drone, the more costly, the more people that are required, the more resources. So you can't provide it in an affordable fashion. And you can't provide the service in a smaller area. You choose bigger areas only. So to cater to small marginal farmers, I think smaller drones are required, 10 liters, 5 liters. And so that is something we and some others are working. And that would be the way to go. That would be the technology point. there is the service angle and the financial angle also. How do you make sure you provide it in the most affordable manner to them so that they can make use of it and benefit from it? That is also there. Mr. Krishna asks, he's asking whether we can play a video of building a drone. Sorry, Krishna, we don't have a video as such, but you can go to YouTube, and if you search for building an F450 or a quadcopter, if you're interested in building a quadcopter, nobody needs to teach you as on date. There are complete detailed videos from step 1 onwards, what components to buy, how to build them, what tools to use. Each and everything is there on some channels of YouTube. And that's how, to be honest, I built my first one as by looking at a YouTube video back in 2015-16. So I may not be able to share a video here, but please go to YouTube. There's plenty of videos. I'll maybe show 1 or 2 brief videos of our drones in action that I can do in a minute. One question from Kranti, whether we build any drones for military. No, Kranti, we are not in the military domain. Military is a different ball game altogether. There are a handful of companies in India who do military drones. A quick Google search will give you the names of the companies. Black Hornet is a extremely difficult drone to build, Kranti. I'm glad to hear that you are aware of this model. You might have seen the pictures of it as well. It weighs hardly 20-30 grams or something, I believe, right? And I'm not sure if you're aware of the price, but it costs about $20,000 or $30,000 is what they say, or maybe more. I might be putting a smaller number. In order to build such a small drone, which can do thermal camera imaging, which can do 10 minutes of flying, imagine it fits in the palm of your hand. You've seen the photos, right? It's very small. It's in the palm of your hand, but it has such capabilities that most big drones cannot have. So it's extremely resource consuming, and a lot of R&D goes into building something like that. Drone swarm, someone asked the question. We're not active on the drone swarm, but there is one company. I need to check which company that is. They're based out of Delhi, who have showcased their drone swarm capabilities during the recent Republic Day celebrations. You can do a quick look on Google or YouTube to see the video of this company, what they've done in Republic Day in India. For the first time, an Indian company has done something like that. Drones are, Rushika, again, drones are known for being noticeable. How do you make them detection? Practically avoid detection. So, different types of detection, Rushika. One is audio based, as in from what distance can you hear a drone. For that, people have been trying to build bird-like drones which make less noise. There are silent drones. I think still research is going on that front. But as long as you maintain certain distance or height, drones are not that audible. So it depends on how close to the target you are, how big your drone is. The bigger the drone, the more size the propeller, the more noise it makes, which means the farther you need to remain from the target in order to be not audible. The smaller it is, you can go a bit closer. But there is some research going on, I think, on propeller-less drones itself. People are talking about ducted fan drones, fusion drones, quite a few new things that are coming up. You can look that up. And the other one, other than audible aspect, is the radar aspect. So in military, typically any drone usually is detected by radar, unless it is flying too low or too small. Radar detects everything. Now, because radars can't detect small drones, the conventional radars, people are coming up with different kinds of radars, different algorithms to differentiate between a bird and a radar, given that bird and a drone, given that drones are extremely small. Radars are conventionally used for missiles, aeroplanes, jet planes, these kind of big items. But for drones, it becomes impractical. People are coming up with smaller radars, differentiating between different objects, birds, or other things. They're trying to do that. So audible and radar, different kinds of ways, I would say. Vindhya, can flying robots also perform tasks other than capturing aerial photos or aerial film? Obviously, so you might have seen some of the applications that I spoke about in my presentation. Be it agricultural spraying, be it drone deliveries, for example, a more important application in medical domain recently. So plenty of applications. Part 2 again. 30 kg don't require 30 kg of downward thrust. Yes, Padu, you can, maybe in case you have more questions about this, you could take my contact from Dr. Ramesh and reach out later on over email. I can answer more questions on a one-on-one. Narayan Murthy, could you throw light on anti-drone systems? Sorry, Mr. Narayan Murthy.
That question from our director, sir.
Hello, sir. Good evening. I am not at all an expert on anti-drones, but I can tell you that there are indigenous and imported systems also, be it from Israel or US or Europe. Some anti-drone systems are there. There are indigenous anti-drone systems. DRDO showcased something, and one or two other companies have been developing it as well. Most of them, so there are two types here. One is a hard kill. That is, you fire a missile at a drone, or you shoot a high power laser at a drone so that it burns it, disables it, and crashes it. Slightly soft kill method would be to capture it midair. That is, you send another drone to capture the drone itself. That's a very difficult task, but that is something people like to do. And another thing is GPS spoofing, hacking the drone itself to try to take it into control and bring it back. These kind of anti-drone systems, hard kill and soft kill as they call it, those kind of systems are there. Hope that answers your question, sir. Ms. Karuna, how the drones can be protected from hackers? Now, software point of view, I may not be able to comment much, Karuna, but there are, as long as you're not connected to anything, the drone, if it is not connected to anything, nobody can hack it. People say that if it is connected to a radio, you can hack that frequency and take it. But drones can be programmed in such a way that they can keep performing their task without any radio at all. And people say you can do GPS spoofing because GPS is something based on which outdoor drones do their tasks. If you do that, yes, you can take control of your drone, or maybe you can send the drone in a direction you don't want it to. That is something you can do. But what if there is a drone that works without any radio connection, without any GPS? What do you do then? So that is something I don't have an answer to, but it's a food for thought. Please think about that or dig up on the internet. These are important questions that some research facilities are working on. Another question, sir, can we run drones using solar energy? Certainly you can, but maybe not multicopters. Fixed wings you can. Do a quick search on Google with regards to world's longest flying solar drone. There's a huge, I think 4 meter or 6 meter wingspan drone that has circled the entire world in multiple rounds, of course. And they do it every year. They keep improving, I think. So search for solar drone. Its entire wings in the body are covered in flexible solar panels. And the reason it doesn't work on multicopters is because of the low surface area that we have on a multicopter. It's absolutely useless when it comes to agriculture drones or surveying drones. It can maybe serve a purpose in powering the sensors also, but to power the drone itself, it's not useful. Only for fixed wing drones, solar energy can be used. Kushika, again, what is your takeaway from Amazon Air Prime? You may not be able to strike it off as a failure yet, Kushika, because a couple of months ago they said they've shut down the program, but today there is a news saying they are successfully implementing it. So take another 2 to 3 years at least to see where this is going. I would say rather than e-commerce or food delivery, medical delivery is the first and foremost application when it comes to deliveries. Please focus on that. There is one company called Zipline in Tanzania, Africa. I think there are case studies of that as well. Please go through that. They've been delivering thousands or millions of medical deliveries over the last few years. Please look into that. It's a very interesting application. Quite a few Indian companies are working on medical deliveries as well in Northeast and different parts of the country. That will be the first and foremost application of drone deliveries. And later on, maybe 3 to 5 years in the future, you might start seeing e-commerce of food deliveries. And that too, only in not so crowded parts of the country, city to start with. And then later on. See, it's not sufficient to do something just because you can. It has to make practical sense and economic sense also. So do think on those terms as well for any application. Kantiraj hybrid drone VTOL, because it has wing like thin stretch, won't it create a heavy drag? Certainly. Nice. So obviously the way you design wings is such that the drag is minimal. So that, okay, so for vertical lift, drags are not wings are not the one that is being used. It's the multicopter that it does. So it may take a tad bit more power. I may not be able to comment exactly because we are not working on hybrid drone VTOL. My team just started building a prototype of that. We are yet to do some kind of a prototype in order to get to a testing stage. But what I can say is the wings are useful when in flight. The multicopter configuration of motors are useful only for takeoff or landing. That's it. So drag obviously would not be a major aspect when it takes off or lands, right? It will be in forward motion. In forward motion, it's the wings that come into the picture, not the motors. So I hope it has answered the question in some format. So I think that's about it. Most of the questions. If there's anything, I think we are already out of time. It's about 7:15. Please do note down any of your questions. Shoot it to Dr. Ramesh. You can share it with me, or you can take my email ID from him and contact me on email as well.
Okay, sir. Thank you, sir. Thank you. Thank you so much,
Thank
sir.
you, Dr. Ramesh.
Okay,
Thank
sir.
you, sir. Now, to express a word of appreciation and gratitude, I would request Dr. G. Ramesh, the Associate Professor of CSE and Dean ACGRIT, to extend the vote of thanks.
Yeah, good evening, all. It's my privilege to propose vote of thanks on this occasion. On behalf of GRIET, I would like to thank our management, Sri M.G. Sekaram Garu, CEO, GRES, Dr. Jendala N. Murthy Garu, Director, GRIET, Dr. J. Praveen Garu, Principal, GRIET, Dr. KVS Raj Garu, Senior AO, GRIET, for trusting us and providing platform to organize this online webinar on drone technology and its applications. I would like to thank to speaker of this program, Pradeep Palelli, CEO and co-founder, Thanos Technologies, for inculcating the required concepts of drone technology into the brains of budding engineers and our faculty. Thank you, sir. Sure, sir. Whatever you have said, the problem statement, definitely we will implement. Sir, thank you, sir. I thank all the faculty and students who have actively participants in this program. I thank all the HODs and deans for their kind support. I express my thanks to student coordinators of this program and the ASC core committee members who took pain time to time in making this event a success. Thank you, sir. Thank you so much. Thank you, one and all. I request all of you, please switch on your video for photo session. Please, I request all of you.
Pradeep garu, namaskaram andi.
Hello, sir. How are you? I didn't recognize
Fine,
from the
fine.
name. Yeah,
Yeah.
now that I see you, I recognize.
Thank
Yes,
you.
yes.
Thank you very much for joining us.
No
I
problem.
also feel a bit odd that when you said the problem statements were given 3 years back and they remained like that. So there's a need for AAC to buck up and then get into this act of doing something.
Right.
You see, sir, lot of times the students display enthusiasm to build a drone.
Right.
So all their efforts are used only to build a drone, and by the time they finish, they many a time they don't pass on what their creation to the next batch. So the
Right.
next batch starts all over from the scratch. That was one thing we observed. But in the application area, you have opened up a lot of channels. I hope the present batch focuses on the application in a more serious way.
Absolutely.
Yeah, and sir, I've seen recently drone being used to lift the hose of that fire engine and fire water onto the multi-floor fire accident.
Right.
But I keep wondering what type of power it should have in order to resist that force of that water.
Right. Right. So this is a very important application for fire engine and also cleaning of high rises, wind turbines. So we even pretty much almost got a confirmed project, but we rejected because of the time it takes to actually build something. We thought we'll rather focus on our current product. But it's a very important application where you can't have everything on top of the drone. You'll be having a power supply from the ground. You'll be having the water also pumping from the ground. The drone basically needs to take care of the weight of the cable and the pipe. That in itself is a major challenge. but that's a engineering design challenge in itself. Say more amount of work goes into it rather than designing a drone itself to understand what kind of a cable to be used, how thick a cable, thin a cable, up to what height you can go, and how does the weight vary with each meter or feet that you raise. So those aspects need to be taken into picture. Very few companies in the world have demonstrated something like this. But yeah, it's again most useful for disaster management, for firefighting, and also possibly for high-rise screening. But for high-rise screening, we've been proposing something like, rather than an independent drone, something like a hanging robot from the top, which can crawl on top of the windows and clean it. But for firefighting scenario, you don't have such kind of scenarios. It has to be a drone. So definitely, it's a possible application.
Thank you very much, sir.
Sure.
Thank
Sir.
you.
Thank you.
Thank you, sir. Thank you so much, sir.
No problem. Thank you. Do share my email ID with any interested students. I can answer their questions over email.
Sure, sir. I will share your email ID. Okay, sir. Thank you.
Sure.
Thank you, sir.
Thank you. Thank you all.
Thank you, sir.
Right, sir. Good day. I take
Thank
leave.
you.
Thank you.
Bye.
Thank you, madam, for joining session. You are not audible, ma'am. You are not audible, ma'am. You can unmute yourself. Okay, now.
Sir, excellent session, sir.
Yes, ma'am.
Yeah, I followed from the beginning. Thank you, sir. Thank you.
Yes, ma'am. Thank you, ma'am. Thank you.
Same thing, sir. What Jainam sir asked, I observed that one in the news, sir. TV news. So multi-stored building fire will be stopped with the drones.
Okay, okay.
Even really very good application, sir. That one is.
Yeah.
Okay, sir. Thank you.
Okay, ma'am. Thank you. Thank you. Ma, thanks to all. Niharika, Manasa, Jayant, and Padmini, Harshavardhini, and all core committee members. Thanks to all. Okay. Thank you. You can leave.
Thank you, sir.
Thank you, sir.
Okay, ma.